is defined by taking what you want over your total possibilities. So if you can remember that, what you want over the total possibilities, then you should be all right. Okay? If I wanted the probability of rolling an even number on a six-sided dice, what would be my probability? If I want an even number. What's the probability of rolling an even number on a dice? 1/2, right? Because how many even numbers are there? 3. And how many total are there? So we'd say 3 over 6, which would give you 1/2. You want to keep these in lowest terms today because we're going to write them as fractions. Okay? So what we want over the total possibility. The geometric part is going to be because we're going to talk about lengths of segments or the area of a shape or something. So that's where it becomes geometric. What you want over the total possible outcomes, I think it's easier to say that than favorable. So here, if the roach is stuck in a box that's 10 inches by 5 inches, 15 inches, what is the probability that it will stop in the red region? And what is the probability that it will not stop in the red region? So if I want it to go in the red region, what is the shape of the red region? Triangle. So if I want it to go inside of the triangle, what do I have to figure out about the triangle? How do you find the area of a triangle, Megan? Good. So 6 times 5 is 30. What's half of that? 15. So we want it to go in 15 square inches. The actual rectangle is 10 by 15, so it could go anywhere within that area. What would be the area of a 10 by 15? Just going to stop you there. Okay. Isn't that gross? So we want him to be in the 15-inch one, but he could go anywhere in that rectangle that's 10 by 15, so that gives us an area of 150. Reduce that. 5 goes into 15 3 times. How many times does 5 go into 150? 30? Oh, this would have been 1/10. Okay. So there's a 1 in 10 chance that it will land in the triangle than anywhere else in the rectangle. What about it not going in the red region? 9 out of 10, right? Because if it's 1 out of 10 for the red region, then it's got to be 9 out of 10 for the other one. What's 1/10 as a percent? 10%. So there's a 10% chance of it going in the red one and a 90% not. Sometimes they answer them as percents. Okay, your first one. A gnat lands at random on the edge of a ruler. Find the probability that the gnat lands on a point between 2 and 10. So probability, what we want over the total possible. Geometric here, we're going to be thinking like area, lengths, da 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 da. We want him to land between 2 and 10. So I need to figure out how many inches or how long that segment is we want him to land in. How long would it be from 2 to 10? 8, right? Yeah, you just subtract them. So we want him to land in an 8-inch length, but he could land anywhere on the ruler, and how long is our ruler there? Careful. It is 12. It goes one more. So 8 out of 12 reduced by 4, 2/3. So he has a 2/3 chance of landing in that area. How would I turn that into a percent? What do you do to get percent again? Yeah, you just do the fraction, 2 divided by 3, and then move your decimal 2 spaces or multiply by 100. This one would be about 67%, right? Is it 66.6 repeating? Okay. Number 2. A point on AB is selected at random. What is the probability that the point is on CD? Probability, what you want over the total possible. Where do we want the point to come from? Yep. But we're picking anything from AB. So I got to figure out the lengths of CD and AB. CD is 4. AB. So 4 over 10 would reduce to 2/5. which would be about 4, or it would be 40% chance. That's all you do. I don't like this next one, so we're going to skip it. The wording is really weird. So number 4. A circle is inscribed in a square target with 20 centimeter sides. Find the probability that a dart landing randomly within the square does not land within the circle. So I have mine shaded up on the smartboard where I want the dart to land. I want it to be in the square but outside of the circle. And inside means what about that shaded region? It's perimeter or area? Good. How are we going to find the area of that shaded region? Good. So to get the area of the shaded region, what we want, we have to find the area of the square and then subtract the area from the circle, or area of the circle from that. Where could the dart land, though? Possibly anywhere. What's my outside figure, the biggest, most area it can land in? Square, right? Okay. So you have to find the area of the square and the circle both. Nick, what would be the area of our square? Can you find the area of a square? 20 times 20, which is area of our square, or of our circle, excuse me. How do you find the area of a circle? Good. Pi times radius squared. What's the radius of our circle? 10 squared is 100 pi then. So if it's me, I like to leave everything in terms of pi. I think it's easier kind of, but 400 minus 100 pi all over 400. Do 400, 100, and 400 have anything in common? But they all three have to have the same thing in common. Do all three numbers have anything in common? 100, right? Since all three of them have 100 in common, then I can factor that out or distribute it out. How many times does 100 go into 400? How many times does 100 go into 100? How many times does 100 go into 400? 4, right? Okay. This would be your probability as an exact answer in terms of pi. 4 minus pi out of 4 chances. If you throw that in the calculator, bless you, do 4 minus pi, and then divide that by 4, and what do you get as a percent? 21%? You guys agree with him? So there's a 21% chance that the dart's going to land outside of the circle, yet still inside of the square. All right. Next one. Same idea. We've got a dart that we're going to throw at the dartboard. We want the probability of it landing in the shaded region. It's probability it's going to land in the 2 shaded regions. Don't think so hard. This is kind of more like your middle school probability. How many spots are shaded? 2. How many total little spots are there? So what's your probability? 2 out of 6, which we reduce to 1/3, which is about 33%. If they don't give you any measurements, then it's hard to do the area of it. Do you know what I'm saying? Yeah. Okay. This one, you don't flip your paper over. We're going to do this one on the back side. You have a blank back side. Because I don't like the circle picture. It's really confusing, so I threw this one on there instead. A dart you throw is equally likely to land at any point on the board. Find the probability of it landing in the shaded, the red area of this figure. Shape, which Alyssa said is a rhombus. So then I have to find the area of the rhombus, which Kendra told her was 1/2 D1 D2, right? Okay. And you said, Trevor, that the diagonals have to connect opposite corners? So what's the length of this diagonal, that vertical one in the rhombus? Would you agree with her, Trevor? Okay, so then I'm going to put 1/2 x there. And how about the other diagonal, the horizontal one? What would that length be? X, good. Well, what's 1/2 x times x come out to be? What's x times x? So wouldn't this just be 1/2 x squared? Okay, that's where we want it to land. But it could land anywhere on that dartboard. What's the shape of our dartboard? That's the outside figure. What would you? A square, good. So how do you find the area of a square? Base times height, so what are we going to multiply together? What's x times x? What happens to your x squareds? Yeah, so what's your probability? 1/2. Or 50%. 50% chance it's going to land inside of the red shaded area versus the white ones up here. Okay, good.